This is for an acoustics lab at ME 4053, also known as Systems Lab. My name is Jeremiah Crane, and my lab partner for this was Raj Saeed. Sorry, he's Iraqi. Couldn't remember now. We were on station 2, which is for the effects for the TAs, but you guys don't really care about that. Next slide. I also don't know what's on the slides, so I have to look back and make sure I know what it is. Introduction for this is the main purpose for this lab was to study acoustics, which, you know, the speed of sound was one. Like, get to find the speed of sound, find how the sound pressure drops off over a set distance, investigate harmonic distortion, and for directivity, which is where sound will change as if the sound's in a particular direction, it will vary as you rotate around it. Next slide. Our apparatus and setup was to put a function generator outputting to a oscilloscope and to a speaker. The speaker would then transmit the signal, and at a set distance we put a microphone so you can measure the time delay between what the signal generator generated and the microphone actually picked up. Next. Procedure for speed of sound I just described. Results. It was actually pretty linear results, as to be expected with a velocity of speed of sound, a kind of wave pattern. They matched very well in that respect. Getting a function we use there for the next slide. In the speed of sound, we get about 350 meters per second, which is a little faster than the theoretical speed, which is 344 meters per second. That can be attributed to the sensitivity of our instruments. Using a standard error analysis, we get a deviation of about 6 meters per second. So even on the low end, we can get down to 344, which is within reason. So our data was actually within 2% of the actual results, or what the theoretical should do. For sound pressure level, we measured the RMS value at different intervals, as well as we took the sound, when we took the time delay. So there's an effect of a speaker at a specific distance called the Rayleigh distance, of where before that distance it fits a 1 over r squared pattern. So you can see the beginning part right there, that it follows that model quite closely. Then right after the distance it breaks off and goes in a kind of degradation of that. And this is a work in progress from here on. This will be the mathematical basis for the logarithmic curves. And then the captured waveform basically is how we captured the data. Took a burst of 5 millisecond bursts, and then measured that. I'm running out of stuff to say. I don't really know too much about acoustics. And that's it.
You spoke for 3 minutes.
That's perfect. That's a 3-minute presentation.
2-minute presentation?
3 minutes for me and 3 minutes for the other person.
Oh, okay.
And that was Jeremiah.
Yeah.
Feedback. How's this presentation going to go? If that would have been his presentation, what grade would you give it?
Probably pick low one. I would mess up.
I mean, you were going on the fly, obviously, since you had to make sense. But because you're going on the fly? Yes, going on the fly. I think you had a lot of times where you had to think, and you work a lot of eye contact. But I feel like the more you're prepared, when you know what you're talking about, you'll make better eye contact. Because I think you were good at the last time. But yeah, try not to break eye contact, I guess.
You did have a lot of errors when you were like trying to think of the stuff. You know, I think it would have been even better if you had just been quiet for a second.